Okay, so as has become sort of an annual tradition, I'm here with Bjarne and Gabby to talk a little bit about this sort of state of the union of C++ 20. But before we get there, I want to start with your keynote for this year.
Yeah.
So can you tell us a little bit, what was the title and what was the content of that material this year?
I was talking about concepts, and I was presenting them as the sort of the future of generic programming. And the interesting bit is that the future is here in the sense that we have an implementation, a second implementation is coming. We have user experience at an industrial scale. So I can finally, after almost 20 years of work on this, talk about it in the past tense. We did that, we learned that, this can be used here, this is a good technique, this is how you can do it, beware of that, this is where it is in the standard, this is what's coming in the standard. This was great, this felt good. I could mention the ranges TS, which is the next generation of the STL, and it's coming along. Cross my fingers. if everything goes well as expected in San Diego in about 6 weeks, it'll be in the working documents. A lot of the concepts are already there.
Maybe for the audience, we should explain what the San Diego meeting is.
Sorry, there's two things I should explain. What's the San Diego meeting and what's concept?
Yeah, I think both of these would help.
I forgot about this. This is sort of, when you're deep in it, you forget about the details. The San Diego meeting is the next meeting of the C++ Standards Committee. And it's in November. And we are at the stage of the process where we are coming up on a feature freeze for C++ 20. In other words, by the end of November, we have a pretty good idea of what C++ 20 is, and implementations of most of it already.
Okay.
So it's not science fiction.
I guess because this is the internet and everything will live forever, we should tell future historians this is 2018.
2018 still, yes. And I think there's another meeting in the spring where the Kona, where the gate really goes down.
But the idea is like you have this sort of feature complete and then sort of like you're working through bugs and issues.
It's like any big project. You have to decide what is the final product to do, and then you have to get everything put together in an initial sort of a binding of everything, and then you can work out the details and the problems when
interactions
has to fit together.
Feature
interaction is very difficult to work out till you have the full set of features, till you have the integrated document. So this is happening.
Got it.
And
back to concepts.
Back to concept, yeah. So what we have in C++ and has had for almost 20 years, more than 20 years, yes, is fully generic programming. That is, you can say, here's a type and a function works based on that type. The problem is you can't say what the template expects from that type. So if I'm doing some numerics, obviously I can take a variety of numbers, and you want to say that the parameter is a number.
Mm-hmm.
If I'm writing a sort algorithm, I want to say that the sort algorithm takes something that can be sorted.
Yep.
And you can read the in the standard. It's been there since 98. It says what it means to be sortable. You have to have a range that's a beginning and the end. You have to have random access to that range. And you have to have a member type, an element type that can be compared.
Okay.
And things like that has been in the standard, and things like that are in the manuals all the time, and they're in the heads of the programmers, but the compiler doesn't read standards. It doesn't read any manuals.
Life easier on
so we have to find a way of getting that stuff into the language so that the programmer can express it and the compiler can understand it and use it.
Got it.
And so basically this is, in my opinion, a step comparable to when we got function argument specifications into C and got function argument checking, we got overloading out of
I
that.
see.
This was actually what I was doing in '79. It's a long time ago, but it's something like that. And so generic programming we moved from a generally untyped world to a properly typed world, and we can express our fundamental concepts of programming directly. And so we've always had concepts. I mean, you look at K&R, Kernighan Ricci for C, from '78. It has integral types and integer types. It says so in the in the standard, but it's not in the code. Now we can write it out. And
Got it.
people will get better overloading. It will improve the expression of ideas. It will improve designs. It will improve error messages and such. There are people, quite a few people, that today says that they have built things they could not have built without concepts.
Got it. Do you think that, like, are there any prerequisites for the talk? Like, do you expect people coming into that talk to have seen the concepts, syntax previously? Are there any things that you tell people to watch first?
I tried very hard not to make that talk into a technical talk. There are 2 or 3 slides that says this is where we are in the process of development, and here's some historical background to it, but it's not a concept tutorial. Some of the things are really simple to understand because we have had them in our heads for decades. People know what sortable means. People know roughly what a number is. Okay, you can go to the mathematicians and they will convince you don't really know what a number is. But for practical purposes, people already know this.
So this is a talk for everybody?
Yes.
Got it.
Yeah. And eventually everybody will be using this. This is completing a part of the foundation of C++ that I've been dreaming on all the time. I have a paper from '81 explaining why we need a template, what became templates. I have papers from the 90s that explains why the current templates are incomplete. Basically, I want to make generic programming very, very similar to ordinary programming. You program in terms of these concepts that is a bit more flexible than a simple type system, and not it's a bit more flexible and still as effective.
It might help to explain why it is important that generic programming just looks like ordinary programming.
Yes. I want programming.
So, for example, Alex used to say, well, if you're writing generic algorithm. Alex Stefanov, sorry. Alex Stefanov. You start from a concrete algorithm and then you abstract to something generic. But most importantly, you tend to make less assumption about what's going on. When you have concrete types, oh, it's an int. Oh, well, I can shift left, I can shift right, which is usually not the assumption you started with, right? Whereas when you're writing a generic algorithm, you write down the assumption. Through concept, you can document that directly in code. Yes. And the compiler keeps you honest. So you write your algorithm, you don't make implicit assumptions. If you do, compiler keeps you honest. Hey, you didn't tell me. Yeah.
So these clear error messages is like one of the big value propositions of using concepts.
It's a side effect of actually saying what you want.
Got it.
The reason the error messages are so poor is that the compiler doesn't know what you're trying to do, it only knows what you did. And so it can't comment from a higher level point of view. So when we go from a concrete algorithm with specific types to something that is more flexible and therefore can be used for a larger range of problems and such, which is one of the reasons the STL was a success. But when you do that currently, you have to rewrite your code using a different syntax, different kind of thought patterns, different kind of code organization. You get into all of this header only stuff instead of using .cpp. Everything changes in that process, and that's unnecessary and basically unnatural. We should be able to express things in terms of the concepts by which we're thinking about them.
Got it. I think another thing that, especially in our pre-discussions here, you were talking about the importance of code organization, and I think that all of these comes together, this idea of being able to express your the organization of your code as well as the semantics of your code more clearly.
Now, concepts themselves do not address the code organization issue. That actually is a different major thing, probably one of the most major things for C++20, which Gabby has been working on for a long, long time. Once we get modules, we can organize our generic and non-generic code identically.
I see.
And so I had one little line on this in the slide simply saying, go and see the modules. So maybe we should go and hear.
Yeah, let's go see the modules. Yeah, but do you want to explain your relationship with modules for people who don't track the details of the language evolution stuff?
So, as Bjarne was saying earlier, the more you practice generic programming, you find yourself migrating all your code into headers, and then get these bizarre notion of header-only libraries. They look very different from ordinary code, where you separate headers from implementations and so forth. It's not natural. So the concept of module is that you state upfront what are the boundaries of your component, your library, and so forth. Usually, you rarely do something from scratch. You reuse some component. You take dependencies on someone else's work. So you state directly what your dependencies are symbolically in the code. So
and
that
for the code organization works.
That's right, the code organization. And then you write what is most important, the interface, and then you put implementation. Now, interestingly, with modules, you don't have to have a different, a distinction between how ordinary code is organized and how template codes are organized. They just look very similar. If you want to have just one single file, that's your module, fine. If you want to have separate, you can have them, and the module mechanism allows you to organize the codes similarly. Now, that is something that we want to have, and we can get there. Actually, we are getting there. The other thing is with templates, code gets compiled over and over again. The same code gets compiled over and over again.
Instantiation sense of it?
Not just instantiation.
It's in general. Things that we have in header files, if we include a header files 100 times, it gets compiled 100 times.
Yes.
Now, in the dark ages with early C, a header file was a couple of 100 lines, and you included it in a dozen source files. These days, partly because of the growth of templates, the header files are tens of thousands of lines, and you may actually include them 100 or 1,000 times. And now you're doing the same work
over and over
over and over then, and the compiler doesn't know it's the same work. Because of things like macros and context dependencies, the same sentence could mean different things in different inclusions, and that means that the compiler has to be careful and do all the work again. This is painful. It's also very old-fashioned. Most languages can do better than that, but we can now do it in C++ because we clean up the code, we minimize the dependencies, we get better hygiene, and the compiler says, "Oh, you can understand it now. I can understand it too," and it runs much faster.
So we get componentization, we get isolation, we get better build throughput. We don't have to parse 100 times just once and reuse as much as you want, and now we get developer tools. Compiler understand it. More generally, semantics are our developer tools, right? When you talk to C# developers or Java developers, they have all variety of kind of stuff that C+ developers drool over, right? Now you can have that with modules, and this is a very important step, for the language itself. And 4 days before CppCon, the C++.
This is the last week of September.
That's right.
Again, for the alien historian.
Yeah, so that will be the 20th of September or something like that. The C++ Standards Evolution Working Group met specifically to talk about the obscure technical details of modules that need to be worked out before we get into.
Don't worry about it.
and we nailed all of those things down, and it was very fantastic progress. All the major compiler implementers were there. Clang, ETG, GCC, of course, Microsoft compilers, and a bunch of tool developers, Coverity, and a bunch of other people were there. And we ran out of work to do because we solved all the problems.
I think it's worth mentioning how extraordinary that was.
Yes.
We have been working on this for years.
Yeah, very literally.
A lot, always literally. Gabby has been doing it, the other compiler writers have been doing it, and we had sort of the conceptual framework, the big picture. We have slowly gotten agreement over the last year or so. And we were now down to details that I will not dare explain without a whiteboard. And most users should never hear about it or think about it. But we are nailing it down. It'll become standards text. And there is a very good chance we are going to get modules into C++20 as well, of course, as concepts, which are already mostly in the working
So these two features, concepts and modules, they complement each other, for good code organization, hygiene, and concept gives you this additional expressivity, and modules brings you this other structure to your code, right? So they complement each other very well. Yeah. So the question is it all?
Well, I don't know. I'd like to emphasize two things. That is, people focus on the sort of the physical results of these features, fast compilation and better error messages. But it really comes by raising the level of expression in the language and making it easier to express the fundamental ideas we're dealing with.
Are you saying like these
physical improvements are side effects of logical improvements in the language itself? The foundation of the language is improving.
And then this is sort of like, I think what you're saying is that's like a underappreciated benefit of this.
Yes.
Everybody gets this sort of like, ooh, better error messages, ooh, faster build throughput. But what you're saying is like, you really want people to focus their energy on really understanding the fact that it's also going to raise the abstraction to make code more
We are generating
understandable.
We are writing better code. We're thinking about it better, and that's why we get the benefits.
It raises the level of how you think about programming, how you write your program, and it is really fundamental to C++.
Oh, and by the way, of course, the code will also run faster.
Yes.
It's there are people who believe that higher level means slower.
Yes.
This is not the case here. Zero overhead or better.
And with modules, we remove some of the horrors, like the ODR, the one definition rule violations that sometimes just kick in without programmers knowing. No, we've removed a bunch of those. Previously, some of them will be left to the compiler to check. Now
so less error prone.
Now we have built the check, or sometimes the fact that it's correct
moved
directly.
It from like a runtime failure to compile time failure with a good error message.
This shall not pass.
And
you get that.
And we get the better error messages and such faster, because there has been repeated, people have repeatedly noticed that code using modules compiles faster than code using workarounds. So we're actually getting a better language, better checking, more flexible language, and having the compiler speed up. Yeah. For the ranges TS from last week, Eric Nibler sent a message out saying that he has two versions of it. The module, the version with concepts and the version using the old-fashioned facilities, and the concept version compiles 25% faster than the old stuff.
And I mean, like one of the things I've really come home for me in the last year as I've been working with a lot of game developers in particular, is the lack of having any standardized way to do this. It's amazing the things that we'll find, like AAA game studios will do in order to, put some thing together with duct tape and wires in order to work around the build throughput aspects of this. So I'm really excited.
People want to deliver their products, and if the language doesn't make it easy, they will find a way.
Yeah, the amount of infrastructure time being spent on this is just insane. The world will definitely have more time for actually building better whatever code that once this thing's out of the universe. So it sounds like you guys are feeling much more optimistic about C++ 20. Mm-hmm. Any other things that you want to?
I am certainly more optimistic about C++ 20 than I was, say, a year ago. And I think I have reason for it. It's such a big committee and such a big project. We're doing things over multiple years. There's 150, 160 people at a meeting, and they all have to agree on something. That's not easy. There's probably as many, again, that contributes remotely. Mm-hmm. This is great, of course, but it's also a problem. I have been, and I am constantly worried about the coherence of the language. How do you maintain it? How do you maintain a direction for the development of the language? You can't just try and be everything to everybody and add every feature that somebody thinks is neat. But how do you actually maintain this? I was asked to give a lightning talk here at the conference, and I chose the topic of the Vasa, the good ship Vasa.
Okay.
And I'll
do you want to
tell
summarize?
it. Yeah, it's sort of an allegory. In '96, the Standards Committee was in Stockholm for a meeting, and we, a lot of us, went to see the good ship Vasa. The Vasa is a beautiful ship. It was built in 1628, wow. And it was going to be the greatest ship of the Swedish fleet.
Okay.
It was named after the new royal dynasty, the Vasa, and it was going to have two duties. It was going to be the biggest and best battleships for fighting, okay. And it was going to be the most beautiful ship for diplomatic impressing the neighbors. And they got it started. They laid down the keel and started working on it.
To build the ship.
To build the ship. And they then noticed there was a snag. The snag was that the opposition was building battleships with 2 gun decks, and if you stick a 1 gun deck battleship next to a 2 gun deck battleships, the 1 gun deck battleship will end up at the bottom with a lot of holes in it. And that's not very good, especially not if you're the flagship of the Navy and symbol of the royal power and all of that. So they fixed it. They made the foundation a little bit wider, and they put another gun deck on, and they added more bigger guns, and they added lots of beautiful statues. It really would have impressed everybody. And you can go and see it in Stockholm. I recommend it to everybody. This is great. There was just a couple of snags here. They hadn't built a 2-deck battleship, a 2-gun deck battleship before, and they made a few mistakes. It was too tall, and it wasn't quite broad enough. Modern calculation says if they had just been a little bit wider at the bottom and the keel had been slightly different, it would have been wonderful. But as it was not quite stable. When they tested it, the way you test a battleship in those days, you take the crew and run from one side to the other. And if you can do that 14 times, the ship is known to be stable from experience. If in seas, they had to stop after less than 14, I believe, something like 5. I don't know this for a fact. So there was something wrong. They sent messengers to the king, who was in Poland, doing something or other, probably fighting a war, because that's what he was very good at. and saying, well, we need to do something else and we need more time, and back comes a message from the king, finish it now, we are ready, right?
Uh-huh.
Reminds me of some managers. Anyway, so they got it put together, they got it painted, they got the guns on, with the trumpets blaring and the flags flying, it sails out to the harbor of Stockholm. A little gust of wind comes, it keels over and sinks. And it wasn't seen for another 300 years. So a lot of people have analyzed what went on there and trying to draw lessons from it. My conclusions, and the ones I've been explaining to the Standards Committee in the 90s and such, but it's been forgotten now, so I'm reviving this story to remind people, is you have to work on the foundation. The foundation has to be right, it has to be solid, it has to be coherent. You can't just add statues and guns. I mean, from the outside, from the sort of the non-engineers, what matters is how beautiful it is and how big the guns are, right? Yeah. It's a flash, it's what you really use.
The syntax and the features.
Yes. I'm saying what I care about is what you barely see. It's down under the water and it has to be right. Just you have to. When you add more features at the top, you have to add more foundational stuff at the bottom. What we have been talking about here, like modules and concepts, are the foundation.
Basically,
for...
people shouldn't think about them as just new features. They're actually those foundational components.
They're foundational features.
Okay.
So I've been telling this story, trying to warn people, and what I want for C++20 is these good foundational features, and then hopefully not too many fancy statues and such. I worry about little features because there's no such thing as a free feature. If you add something, it has to be specified, it has to be implemented, it has to be tested, it has to be taught, it has to be learned.
And of
all
course,
of those are cost. Yeah, and then there's always interactions with other features. Sometimes this is great. Little features can be great. In C++11, we got range 4 and we got auto. Wow.
Yeah.
These are little things, but they really help people, help lots of people.
Yeah, and that actually goes back to something I used to say, which is that a programming language is a response to challenges of its time,
yes.
And language has to evolve or die, and so when you talk about the foundation, it's not just that the challenges of your time. You have to have the right foundations. Even if you have the right foundation 10 years ago, you still have to revisit the assumptions and make the foundation much more solid too, in order to take on the challenges of of your time.
Stability over decades is a feature.
Yeah.
People complain about compatibility problems and this old bad code. But this old bad code is somebody else's livelihood. It's somebody, it runs something like maybe that camera. People don't rewrite it just to be fashionable.
Right.
And so you need stability, but you also need evolution. And the tension between those two things are quite difficult to deal with, but it's essential.
Got it. All right. I think that's a great place for us to wrap up.
Sure.
Thank you both for coming.
Oh,
Thanks.
Thanks.